I'm here to give you an explicit example of a homotopy, and in particular the circle centered at the origin of radius 3 is homotopic to the point 5,1, or 5i. And notice this drawing is not to scale, in particular because I want some room to draw some extra stuff. And I want to explicitly give you the function that I'm going to use. So, or family functions actually. We normally say h of st, h for homotopy, s and t are the two parameters we might say. And let's just start with thinking about how this might work. I'm going to start with a circle and I'm going to move it up to this point essentially. And I'm going to shrink it down too. So I'm going to start with 3 e to the it, where I need t to be between 0 and 2 pi. So that's going to give me the parameterization of the circle going in a counterclockwise direction. That's completely standard. Except I'm going to tweak this, because for s, when s is say a half, I might want this circle to only have radius 1.5, and maybe I want it to be at 2.5. So maybe when it's halfway up, I might want to have it the center be, oh, what's this going to be? It's actually, since this is not to scale, oh, maybe I should have tried to scale. It's actually going to look something like, I want it to be like this should be h of 1/2 t. So I'm going to plug some stuff in there, and then as I go up higher, maybe this will be something like h of 3/4 t. Oh, and I should mention, this we want to be h of 1 t, and this we want h of 0 t. And then maybe I'll give you 2 other kind of extreme examples. Maybe I won't, because they'll be too messy. And then right when you're at the top, you should have just a tiny little circle. Maybe this is like h of 0.9 t. The t is going to stay in there every time when I draw this graph, because what I want is I want to parameterize it, right? A t tells me what to draw out. I want to go from 0 to 2 pi for all of them, because they should all be circles. But notice what's happening. I want the circles to do 2 things simultaneously. I want them to rise, go up, and I also want them to get smaller. Well, I can get them smaller. So, right, the green circle is smaller, has a smaller radius than that, smaller radius, 0 radius. I can do that by just multiplying this by, I don't know what I'll do. I'll pick green. I'm going to multiply this by a factor of 1 minus s. And notice what happens. When I multiply by this, when s is equal to 0, which I want to be this big circle, the radius of the circle is going to be 3 times 1 minus 0, which is just 3, which is good, which is what I want. Up at the top, I want the radius to be 0. But that's when I want s to be 1, so that's 3 times 1 minus 1, which is 0. So that'll give me the radius I want. So that takes care of shrinking the circles. I still need to make it go up, though. And I can do that by, maybe I'll do that in blue. I'm going to add to it 5i, because eventually I want it to go up to 5i, except I don't want it to always be raised up 5i, right? If I just had 3e to the it plus 5i, what I'd have is I'd have this red circle, except it'd be centered up here. The circle would look like that. So instead what I want to do is I might just multiply this by s. So again, when s is equal to 0, I get a radius of 3 times 1 minus 0, which is good. And I'm going to raise it up 5i times 0, which is just 0, so I get exactly this red circle. When, at this point up here, when s is equal to 1, I get a radius of 0, but I raised it up 5i times 1. So I basically get 0 plus 5i. And in between, it's going to continuously vary. And when s is equal to 0.1, I'm going to get a circle that's you know, almost 3, but not quite. It's a little bit smaller than the red. And I'm going to raise it up by like 0.5i, which is like right there. So I'm going to get a circle that's just a little bit smaller, that's just going to go right inside and overlap a little bit like that. So that's an example of a homotopy. And this is an example of how to come up with a formula for it. Thank you.